Hello, YouTube viewers. Welcome to my show, Rocket Monday. In today's episode, we're going to talk about rocket staging. So let's dive right into it. Well, first we have to understand why the heck do we even go through all that trouble of making a rocket engine, making an awesome fuel tank, and then just throwing it away. Why the hell we do that? Well, one thing you have to understand, basically two core factors you have to understand. We don't want orbital height. We want orbital velocity. Those two things are very separate. Like you can design a cannon that just throws something to or basically orbital height 100 kilometer. That's easy. Problem is sending it fast enough. Basically, or that's why rocket goes like this. Once it's outside of atmosphere, it's like because we need speed, not height. So how do we get speed? We get it from acceleration. Then what is the biggest hurdle of acceleration? Mass. So heavier you are, you might be like, okay, I'm only adding 1 extra kilogram. In case of a rocket, forget about it. Like you added 1 extra kilogram in a rocket that is like even designed for 100 tons, most likely it will not reach orbit stably. So unless it has extra fuel and extra margin of error, but you get the idea. Basically, you want your mass as low as possible, then you want as high of acceleration as possible. So can we do single stage? Yes, absolutely. Physics is not saying, oh, you cannot do that. And heck, on moon we have to do single stage orbit. On Mars we will do single stage. So it's not that single stage is like physics is like thou shall not have single stage. Physics is not stopping you. It's just not cost effective. That is the core reason we don't do single stage. It's like if you have $1 billion and somebody's like, okay, take $1 billion, give me a space vehicle. You'll be like, okay, this staging space vehicle can put like this much like let's say 100 ton, and the single stage can do 1 ton. What will you buy? That's the whole thing. Like you don't have to think in like, okay, I made it in Kerbal Space Program. In real life, you have to design it, build it, engineer it, and you have to pay for all the people. And not to mention, fuel also is not free. So in that reality, cost is flat out not recommending single stage to orbit. Now SSTO is possible in physics is not stopping you. Like our first lunar modules were single stage to orbit, so it's not impossible. It's just on earth in real life is just multi-stage is wiser choice if you have a budget. Again, everybody does. Even Elon Musk is like low on money. Jeff Bezos is low on money because rockets are on a whole different level. Like Ferrari is like, bro, Ferrari is such a toy. It's like one of those engine is like F1 engine is like hundreds of Ferrari. So you get the idea. Multi-stage is wiser. Now almost all rockets that have reached into orbit, barring some sounding rockets, most of them are generally multi-stage system. Why? One simple reason is like, think of it this way. If you're taking the weight of, let's say, Falcon 9 stage 1, it's basically 9 inches, lot of thrust, and it's 22 tons empty. 22 tons. Now what if you like let's say made it bigger, and you're like, okay, made it bigger, and then you added more engines to add more thrust, and you added more fuel so you can drive those engines. Can it go to orbit in one stage? Absolutely. Yes, your payload will be much smaller. Why? Because you are not dumping the extra energy. Basically your tank is still there. Tank adds basically mass slows down your acceleration. So even though you have quote unquote more thrust, it's not translating into your orbital speed. That is why we want our mass to be so low. If you just ditch the tank away, awesome. Like if let's say for some reason, some in future design, somebody can design a solid rocket motor which literally burns away, rather than having the same height, it burns burns away. We will have single stage to orbit in all ICBMs after that. Like if somebody can come up with that. So right now what we have is a casing. So if we can't throw away the casing, people have to ditch the whole damn stage. So that's the reality. Like you might be thinking like, is the fuel tank really that important, like in terms of mass capacity? Yes, it is. And not to mention, this also allows us some extra leverage. Basically, let's say you want a first stage, you will have different requirement. When you are talking about something that has to work in space, it will have a different requirement. But let's say you are talking about something that has to reignite multiple times for another thing, you will have different engine requirement. So multi-staging also has like this blessing in disguise, where you can, oh, this is a sea level engine, let's design, fine tune it for that, and have like simple geometry. And then you're like, okay, this is a space engine, you want most amount of mileage rather than thrust by a hydrogen engine. So that is why we do staging. It's like, it's just not cost effective to do single stage. Physics is not stopping you. Do not make that mistake. Like people say like, physics does not. No, physics allows it. It's just stupid. It's like, yeah, build a 500-meter long robot, basically rocket. It's like, yeah, not happening. So all those things take into consideration. So how do we achieve staging? Well, there are many types. Obviously you can easily see the variety of rockets, so you can understand that there are multiple types. Design directly defines it, whether you're gonna have a multiple staging, you're gonna have single staging is a two-stage rocket, or you will have like serial staging, one after the another, like a Falcon 9. You will have parallel staging like space shuttle or Russian rockets, and sometimes mix of both, Russian rocket again. So There are many types. So let's look into the detail of serial staging. Now, serial staging is the easiest to understand, it's the simplest and most commonly used. And why we call it serial? Again, if I'm familiar with your 9 standard study books, you will have like registers in electricity where you apply them one after the other. That's the same thing. So we do that. Now, how do we physically attach it? Like that's a big thing. Now, there is one thing working for you is that you are providing thrust. Basically, you are providing Newton. So your joint does not have to like we stand against pull force. Basically, it's not like, yeah, I'm gonna pull it now. It has to push it. So you do not need too much structural basically clamping force. However, you do require it to be stable. Why? Because rocket shakes like there is no tomorrow. So it's like you have to design something that can withstand it. Otherwise, you cannot just keep it there. Physics wise, you can do that. If you run a simulation, your simulation will say it will work. It's just when in reality you have a little of wind, the stage will fall off. So that is why there is a serious clamping system is done. Now, older system was simply explosive bolt. We had metal clamps and all that, and we put the explosive powder and tada, we blow it up the moment basically we reach the staging point. Now, there has been a recent amazing movie that randomly somebody figured out that Columbia Studio literally recorded a whole Apollo 11 mission in basically IMAX camera of that time, medium format, amazing quality, but they never did anything with it. So somebody found that, made a whole movie out of it. The staging event of Saturn basically 5 was so huge. Basically, the stage one when the sound reached the ground level, and I did not realize that there is actual sound of that. It's not a CGI or effect. There is actual sound. Like you can hear the rocket like the explosives. Again, it's a big rocket. You are talking about something that is 100-meter tall plus 100 around 50-meter tall. So again, explosives were also chunky things, because if you use soft metal, it might just collapse the moment you start to fuel it up. So they had something very strong, and not to mention you need something even stronger explosive. So you can see it like giant shockwave comes out. Like it's amazing. So we used to use explosive bolt. However, from day one, Falcon 9 was designed in such a way that it had to be reusable. So they could not just go YOLOing everything. So they designed pneumatic systems. Now, there may be hydraulic systems involved. Hydraulic systems as a catch-all system. Basically, pneumatic system does the work, and hydraulic is just locking or unlocking system. Because you have to understand, the vibration is your enemy. That is the main reason people simply go with explosive bolt. Is just make it a metal system and we'll break the metal. It's that violent, so to say. So pneumatic system benefit, it has the usability. Side effect, it is much more complex and expensive and all that. So you must reuse it multiple times, otherwise it was waste. Now this allows us to dump basically sea level engine and tank. Because now you have dumped the engine, which are the main weight, and the fuel tank, your rocket is much more lighter. So if you have, let's say, 1 kilonewton of thrust, 1 kilonewton of thrust pushing, let's say, 30-ton rocket versus 1 kilonewton pushing 3-ton rocket, again, you can easily understand 3-ton will go much faster. And not to mention, since you are outside of atmosphere, there is no drag. That's why you will always see people will try to ditch the fairings as quickly as possible, because if the engine is firing, if you drop the basically fairing, your engine will literally pick up extra booster. It's like nitrous oxide to your engine. It's like it is so big, so prominent, that in case of Falcon 9, they have to tone down the engine, especially the second stage, once it starts to gain speed. It's like because they do not want it to accelerate beyond 5G, because it's unstable for satellites and all that. Again, satellites are tested for higher Gs. It's just that thou shall not push your satellite, thou shall not push your luck. So we want to keep it down, so we just tone down, hey, chill down, we throttle the valves and all that. So you get the idea. Basically, we want to trim as much fat as possible, as quickly as possible. Otherwise, your mass to acceleration translation will not be very good. So serial staging. So what about parallel staging? Well, parallel staging allows you to have boosters. Now, boosters, I mean, instead of having one after the another, you can have multiple in the same go. Now, space shuttle is very unique in this regard, because this is one of the type where you had the engines that started on the sea and reached to orbital velocity on one go. Basically, there was no turning off this engine or having something else. It's just this engine split and it reached to orbital velocity. It was that powerful. However, while it did have the speed capability, it did not have enough thrust on sea level, so they added boosters on side. So these boosters will just push it along. Once it dumped enough energy into it, they will fall away, and this whole system will reach to orbital velocity. The tiny engines that you see in the back, those will be like for maneuvering. Basically, It reaches orbit in one go. It's just like one engine. That's why this is one of the most parallel of parallel system. Now let's talk about Russian system. This is parallel in stage one. It has a stage two, so it is a serial. So it's like parallel plus serial. But what do they do is like they realize early on is that if they can have multiple engines, they can get a lot of thrust out of it. Problem is those engines are very heavy. Like fuel tank versus engine is much more heavier. So they decided, hey, let's put as many engines as we can and then throw it away. So they will have pod-like structures like this. So you have core pod that is classified as sustainer engine. So it will keep going on as long as full stage is working, and then we'll have booster. So you launch it up. Why you want something like this rather than a solid booster? Simply because it's controllable and it has better safety requirement than this. So you launch it up, it has extra thrust to fight against the gravity to get the acceleration. Once it gets there, once it's reaching a point where it's like, hey, this can sustain it, it's like, okay, they ditch the whole rocket engine without changing the fuel tank. So again, because the engines are so heavy, the rocket gets extra momentum, basically not momentum as in like extra oomph. So they goes to like a higher orbit, and once they are in their quote-unquote orbit, they stage the rocket. So this is very unique because this is true parallel, and this is a parallel plus serial. Parallel first stage, and then you have serial second stage. So, and parallel staging is also advisable for many scenarios. Basically, if you want to make a cheap rocket, it sounds like a cheap rocket, but in reality the economics works backwards for that. But that is why you will see a lot of Indian rockets will have multiple tiny rockets, and Atlas, old series of Atlas, basically Atlas 2, Atlas 3, Atlas 4, those will have also multiple small boosters. Those are added in parallel to stage 1 because they just want that extra oomph to get off the ground. And that also allows you to control that. Like let's say you have geostationary payload, you will put more side. You have low Earth orbit payload, you will put less. So that is why we want to utilize parallel staging. So what can we expect in the future? Well, you have to understand that staging events is a one-point failure. Basically, bad things can happen when you have like actual explosive going to. So things could happen. Now there is a very good footage of Falcon 1, the first rocket design they built, third launch. And what happened is like when they did separated those things, it had apparently still had little bit of fuel left, but because the weight mass is now less, it accelerated and hit the damn rocket. And that was a big issue in basically Saturn V. Saturn V literally had multiple rockets, like small solid rocket motors. Sole job was to create separation event cleanly. Basically, if the first booster, let's say you detached, you explosively fired them apart, they will have inertia, a little bit of inertia dumped by the explosive. They will go far apart. Here's the, it will hit it back again. So to make sure that hit it back again and kill everybody does not happen, they had small rocket motors that will slow it down, and they had extra small motors on the second stage to give it extra speed. So they make sure that separation between those two can never, no matter what happens, can hit it again. So if you see the movies where they show you like small 3 rockets engines are going and then the main engine fires, that's the reason for that. They wanted to make sure there is giant gap between those two, because otherwise you can see that I have provided the link down where it's like the stages goes by, everybody's like yeah, and then it's like bam. So you don't want that. You want as few staging events as possible. So 3 stages is no longer like viable as it used to be. Then we are also moving away from explosive, because again, how many explosives you have to have in let's stage this like this, where you have explosives on the side, you will have explosive second stage, third stage, fourth stage, lot of explosive. You don't want that many explosives. Not only it's expensive, it's also unreliable. Again, we have been using it, but you have to understand that sometimes it happens like metal does not break apart, rather than it just deforms. Tada, you are stuck. So people want to move into more reusable territory, so explosive is not reusable. So all the designs of the future are generally dual stage system rather than something this complicated, like New Glenn, Electron rocket. Most of the things are dual stage, and most of them are using clamps rather than relying on boom boom event. So that's the future of our basically system. And SLS is still stuck in this parallel and serial stuff. Basically they'll have parallel stage and then they'll have serial stage. Again, no wonder it's so expensive. So this is the reality of staging. So I hope you liked my presentation about staging. If you liked it, please click the like button. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your extra disappointment, and please leave a comment because I reply to all of them. Subscribe, share it amongst your friends if you like, press the bell icon if you're free, and as always, thanks for watching.